I'm Nick, and I'm a first-time speaker, so let's all collectively pretend like I know what I'm about to do. And I'm going to talk about things I've learned from other programming languages, because in my career, I've learned a lot. I've worked in a lot of different languages. I think this is all of them, but don't quote me on that. And the first thing to note is just that each language has a different way that it approaches thinking about code. And this comes from both the structure of the language itself, as well as the way that communities have created the libraries that you then end up using when you are working in that language. And so it guides your thinking. It helps you to explore different ways to contemplate how to write code, how to organize your thinking, and all of that learning is expressible in any other language. I mean, that's part of what makes them Turing complete, right? So this is really about, hey, we can look at some feature of another language, some way that some other language likes to think, and then how can we apply that thinking either directly or as inspiration for something to do in Ruby. So I'm going to talk about 4 specific things: curried functions in JavaScript, companion objects from Scala, interfaces from Java, and beans from Java's Spring Framework. Unless you think I'm a Java fanboy, no. So curried functions. I'm glad you got that. So canonically, curried functions are just a function that returns a function. This is a very straightforward JavaScript example where we're rewriting the addition operation as curried functions. This can very directly be translated to Ruby using procedures, but we also have this neat little thing called .curry. All this is saying is, hey, I'm a function that takes 2 parameters, and you give one, and then later you can give another. So I first learned about curried functions when I needed to tame callback hell. I'm going to blaze through the JavaScript because we're here for the Ruby. So this is a big chunk of JavaScript that goes through a directory and creates a bunch of different images preserving aspect ratio. And we're going to recompose it into a much prettier curried function setup. So the first thing that I did is I pulled out the bit that gets the aspect ratio into its own function, placed it there. Then I pulled out the bit that does the image resizing, placed it there. And now at the bottom, I've got this really handy little block of code that really eloquently describes everything that I'm doing. All of my code blocks are named, right? Read the directory for each file, get the aspect ratio for each width, resize. Much more legible than before. So now for the Ruby example that you're all here for. So this is before currying. We're going to move a bunch of objects from one location to another in S3. Now, ironically, when I curry it, it gets a lot bigger. So what do we get from this? And don't worry if you can't read all the stuff. I'm going to go through each piece of this code. So the first thing that this lets us do is it lets us slice up our code in a really novel way. We can kind of pull out middle steps. So what I'm doing here is I'm building a couple of different iterators that I can then pick up and carry around and do anything with. So that's what I mean by pull out the middle slice. And then that lets me recompose my code in terms of functions, right? We're all used to dot chains or mix-ins, but this kind of lets me do it with functions as well. I can do this composition step, right? So I can take my iterator from before, and I combine it with a little slice of computation to do the copying, and I get my resulting code. One of the things that I really value from doing this is when I stick to a very functional style, I have a very clear description of all of the dependencies that my code has, both in terms of literally the client, but also any information that I'm going to need to use to do what I'm about to do. Because I can just look at the function signature. There's nothing in there that doesn't come from those 2 parameter lists. This then, of course, makes it really easy to do dependency injection because all my dependencies are parameters. And that then has the further on effects that it's really easy to test each function because we have no need for state. And I found that when I go to write my tests, I just go down my library file, write a function or 2, write a test or 2 for each function, and by the end of it, I've got 90 to 95% test coverage without ever having to think about it. Right? So just to reiterate, we slice up the code in a different way. We can compose my functions. We have very clear dependencies, which makes it easy to do dependency injection, which makes it easy to do tests, and it makes it easy to get full test coverage. Any quick questions about curried functions? All good? Sweet. All right, companion objects. This is a concept from Scala. So we have kind of a singleton object that's the same name as a class. And this is a core language feature in Scala. And they have a bunch of special relationships. And the one I'm going to point out here is that they can access each other's private aspects, be those member functions or variables. So we can kind of pull this off in Ruby using introspection, but that's not great. So instead, what I ended up doing when I beat my head against the wall for a while, I was like, how can I take inspiration from this? What can I do? I really like this pattern. It feels good. What am I going to do with it? I ended up doing this kind of stuff. So I've got some module, and I've got some boilerplate at the bottom that lets me handle the new while having the names be the same. And then I've got this struct that I'm extending with the module. So what does this let us do? So this is, again, an example of moving around files on S3. And again, I'm going to go through each block of code in this. So don't worry if, right? So the first thing, and it's fitting that I learned Scala within the context of Apache Spark, which is a distributed computing thing, because the first thing I think this lets us do is really cleanly separate the data that we're going to use to do our computation from the state of that computation. Right, so the struct between the prefix, the bucket, the prefix, and the continuation token for the pagination, that's all the information that we need to actually do the computation. But independent of that is the state of the iterator. And because I've got them separated, it's really easy to hand that around and get along with my clones. So the next thing it lets us do is this really appealing, to me at least, split for my statics and my methods, where I can put all of my transformations in one place, and I can put all my actions in another. So I've got on the left here under transformations, the pagination action, right? I'm transforming my iterator into the next page, but then the action of each iterator is the classic each. The next thing, I've been calling it dependency application because in my mind it feels sort of like the inverse of dependency injection, but I can take any data structure that represents this computation that has these little bits of data, and I can apply these functions and run with it. So it kind of feels like I'm applying the dependencies to some data. So again, what this lets us do, we can distribute our computing easier because we can separate the data that we're using to compute from the state of that computation. We can separate our actions and our transformations, and we can apply our code to any piece of data. And that last one has been particularly useful, again, in testing, because I can just write down the state that I want to start from and go from there. All right, interfaces. Some of you are older like me. All right, so interfaces do show up in other places. I think canonically they started as abstract classes in C++, but whoop-de-doo. All we're doing is we're describing all the things you're going to use descendants of the class to do in one place, but we're not actually going to describe any of the code that does it. So in Ruby, we can pull that off by raising exceptions, but again, not very satisfying. So what I've ended up doing is I've started wrapping all of my dependencies, and this is inspired by the interface pattern, even if it's not directly the interface pattern. So here's a snippet of an S3 wrapper. Again, gives us an iterator for the bucket items, gives us a function for moving. And here's a real-world example from a chatbot hobby project I've got where I'm interacting with Dialogflow. And Dialogflow, for a lot of valid reasons, but still painful reasons, has these deeply nested complex data structures that it thinks in. And so in order to do the request, I have to build all this data structure, when really all I want to do is say, how do I respond when a stranger says hello? So what does this pattern let us do? It lets us write our own domain-specific language because I can say the action that I care about instead of what the library code likes to think in. It makes it easy to list every action, every interaction that I'm having with my dependency because it's only in one file in one class. So I can just search through that class for every instance of my client and I can mock that. It also means that I can easily think in the data structures that I want to think in. This is a sort of same thing but different for the domain-specific language, except of course it's about the data instead of the functions, right? So instead of thinking in the detect intent request, I can think in terms of a string, and it makes the rest of my code a lot simpler. So, like I said, We get to write our own domain-specific language. We get to clearly list every action that the code performs. We get to makes it a lot easier for us to mock our tests, and then the rest of our code gets to think how we like to think instead of how the library we're working with likes to think. Any quick questions? So I'm blazing through my talk. All right, object graph. So this one's a little wacky. It's one of the harder ones to think about because it's a framework, not a core language thing. So the Spring Boot framework lets us do this wacky thing where we can define components and we can define configurations. And then what the framework's going to do is it's going to stitch these two together. And it is kind of Rails-like in that sense. So what I've got here on the left is I've got these functions that define the various dependencies. And on the right, I've got the place where those dependencies get used. And the Spring Boot framework will actually take each of those beans and it'll inject it into the parameter list for that and just call it. It's kind of wacky to think about, and it turns into a graph. So theoretically, we could create some sort of auto-wire system using the new type system, because it is available at runtime. We can use any of our classic Ruby introspection tricks. And of course, this is very similar to the Rails-style naming conventions, even if it is forking off of a fundamentally different set of operations. And what this really lets us do, this is a thing I'm a big fan of, is separating the what from the when. So I've got one place where I'm defining all of my actions, right? In this case, the wrapper. That's why I presented these two together, because they really work hand in hand. So each of my wrappers defines the different things I might do with this stuff. But my top level code defines when all of those things happen. Similarly, I've now got a graph of how all my pieces connect. Of course, drawing that graph with pencil and paper might be challenging, but that's why we have code. So, just to repeat, when we think in terms of an object graph, we're really thinking in terms of separating what we're doing from when we're doing it, right? You can think of a graph with the nodes and little things that step in. And then we've got one place, or more than one if you've got script code here and there, where our top level code shows how everything connects. So here's a real world example putting everything together. So this is a hobby project. By the way, I highly recommend hobby projects because it's the only time you get to write perfect code. And once you know what perfect code looks like, of course it's in the eye of the beholder. Once you know what perfect code looks like, it's a lot easier to do it anywhere else. So this is a hobby project that connects Airtable as a contact list, transcribes a conversation with a bot to Slack, and of course it's a chat bot. We can see I'm using a bunch of the different features in here. And all of this code is a lot easier to read than trying to cram everything that each of these steps does into the endpoint handler, right? Yeah. So what I told you, we talked about curried functions and how they let us slice up computation steps in novel ways. And I really am a big fan of that thing that I talked about where you slice out the middle, because usually it's pretty hard to pull apart your code when it's nested like that, because like how do you get the middle out? Well, curried functions is a great way to do that. Companion objects, which give us a lot of inspiration for separating our data and our state, our actions and our transformations, which is just, I don't know, it's an easier way to think about and to communicate the code that we're working with. Interfaces and all the advantages that wrapping things gives us, and beams, the separation of what and when. So we have a lot of time for Q&A. So who's got questions?
Thanks. This is an interesting talk, but the thing that I'm a little worried about is it's not very idiomatic Ruby, what you're showing up there. I think you have a mix of ideas from different languages. But you can do a lot of things like what you're saying in Ruby without all the complexity you have in there. For instance, on some of those slides, right, you're using class variables, which are really dangerous, right? Because if you get into inheritance, right, and you have subclasses, right, if that subclass changes that class variable, it's gonna mutate the variable in the superclass. So there's a lot of dangers in that code.
Yeah. Well, so one of the things to note is it's challenging to find toy examples that'll fit on a slide.
Okay, that's fair. The other thing I was a little worried about too is you're talking about how you're trying to compose things, right, using dependency injection. But in the classes that you're showing in the code there, you don't actually inject anything through the object itself. So you have like a class and you have a method. And you're just putting methods within the class, but there's no state or any kind of constructor that you're constructing the object on. And so in object-oriented programming, right, you want to have an object, has a constructor, you inject your dependencies,
Right.
and then you call those.
So kind of feels like what you're asking about is how does this relate to when we should do object-oriented versus functional programming? And ironically or interestingly, that's one of my favorite interview questions. Whenever I'm interviewing anybody, regardless of which side of the aisle I'm on, I will ask, what is your understanding of these two things and when should you use either? So interestingly, this top pattern, which is actually just the builder pattern, right, where I've got the incoming message and I'm constructing it out of things, that's what happened when I spent a while trying to figure out how to use curried functions in my project. So that goes back to the thinking that regardless of whether or not we actually take the construct from another language, the encouragement to think in this different way can give us new insight into how to write our own code. There's also a few places where trying to apply one thing from one language to Ruby never resulted in a useful pattern, but did result in a deeper insight for how Ruby itself functions. And that sort of goes back to I know there's a number of talks here that are about things you really shouldn't do with Ruby, but you can. And again, playing around with a language in that way does a huge benefit for your understanding of the deeper ways that language works, as well as may yield some useful patterns for how to organize your code.
Yeah, that makes sense. I'll ask one more question. I promise not to hog
We
this.
have plenty of time.
The one thing I wanted to ask you, have you looked at dry RB? Because some of the functional aspects that you're trying to do here is great. I like where you're going with this, but you might want to reach for dry RB actually to give you some of that like dependency injection, being able to have like a monadic pattern, right? So you can have just a success or a result type thing. Like you're kind of scratching the surface here, but if you were to bring in dry RB, you would actually get a lot of superpower with that.
So what I'm hearing is encouragement to check out dry.rb, which I haven't checked out before. One of the reasons why I've worked in a lot of different languages is I keep trying to work for Ruby shops and not succeeding.
How has learning Ruby affected the way you write other programming languages?
Yeah, thank you for asking that. I had a list of 10 things in the talk proposal, and they said pick 3. But it turned out 2 of them were linked. So Ruby, I feel like, really what Ruby taught me is that code can be beautiful, which is really sappy. But then what happens is I write code that I'm really deeply unsatisfied with. This is 3rd or 4th rewrite of this same code base, and I kept being unsatisfied with it because it didn't feel beautiful. And then once I got it to the point that it was beautiful, everything made so much more sense. And so Ruby kind of taught me on a deep level that if it's not aesthetically pleasing, there's a better way to do it. And then once I get to the better way, I'm like, yeah, this makes way more sense.
Yeah, I'm curious, what are your experiences, on a larger team, getting them on board with some of these new patterns and really novel ways of thinking through Ruby or another code?
Yeah, so one of the big things that happens is just people have inertia, and that inertia comes from, hey, I've already got a plan for how I'm doing this next step. I've got pressure from my manager to accomplish this thing. I've got pressure from product on the timeline. So it generally ends up being more like planting seeds that then come to fruition later. That said, this particular bit, the what from the when, so my current gig is I'm doing a lot of support engineering, and we have to do a lot of fixing our systems when they break. So we've got a lot of utility scripts, and it was really useful and was really easy to get a bunch of my more junior programmers on board and contributing to these tools when I separated the library code from the script code. And then the script code, which is breaking all the time because we're not the core engineering team. So the core engineering team changed the system and the script breaks. But the script then functions like documentation. In fact, the first generations of the script were literally taking the runbooks and turning them into code. And so I took, this step, and I defined that step in the library, and then I put it in the thing, and now you can just read the code and say, okay, I got to do this step, then this step, then this step, then this step. Without having to get into the weeds or getting distracted by the weeds of how each of those steps are accomplished.
So just by way of encouragement, I've done a lot of bad things to Ruby programming language over the years. You can probably find that all over the place, but a lot of the things that have been done that you say these are anti-patterns, these don't make sense, eventually those end up getting merged to language. So by way of encouragement, please do experiment, please do try new things, give those to the Ruby bug tracker. A lot of times you'd be surprised they end up in language. I'll say at one time, this is all magic, and then Matt's merges it, and then I had to recant my entire talk. I'm like, I don't have any magic anymore. Quit stealing all my thunder here. But as far as functional patterns, I'd be very interested, and this is kind of my question, what do you think of stuff like Raptors and a lot of this isolate object space, and what that might kind of evolve Ruby into over the years?
So to be honest, I don't really know what ractor means as a word. I kind of want to crack a joke about monads and endofunctors without knowing what any of the words mean.
So Raptor is Ruby actor model kind of based on Erlang, where you have isolate state, you can't really do anything with it, and there's a very real chance Ruby ends up going into deep functional land because of that, because there's no way to use object-oriented kind of stateful stuff in there.
So my understanding is basically one of the major advantages of functional programming is the ease with which it does concurrency, because of its restrictions on how you're modifying state. And so, but also some of the experience that I've had trying to build larger functional programming projects, some things don't fit into the functional programming idiom well. And it can get really confusing trying to think about certain things when you're trying to wedge them into that. So that's where the diversity of thought patterns, I think, really comes in handy. My brain's poking at me and saying, go back to the Scala companion object with that sort of novel combination of, I've got my pure functions, but then I've also got my data and my state, and how that interacts with the distributed computing. So.
Hi there. I just have one question. So
Yeah.
being a polyglot, have you found another language that's as ergonomic as Ruby?
Scala.
Scala?
It's the only one that feels like Ruby. It's got a lot of things that I didn't realize that I loved about Ruby until I noticed that they were also in Scala. Like one of the novel things, the code, like when you're in a class definition, the code that you're writing is the same kind of code as the code that's inside of a function definition. Contrast that with like C++ when they're very different kinds of code. And Scala is one of the few other languages that I've noticed. I mean, I know Java's the same way. It's not Java. JavaScript's the same way. Python's the same way. But Scala is one of the other languages that I've noticed that is also the case and is actually used by the community.
I'm new to Ruby, and one of the things I've been very impressed by is PRY. I was curious if your thoughts on like debug and all these other languages and how they compare to Ruby.
Yeah, compiled languages do have a bit of an advantage with your debugging tools, but then you don't get things like your REPL console. So one of the things that I like about some of the patterns that I've used here is when I want to debug, what I generally find myself doing is rather than putting in like a price statement somewhere in my code base, I'll actually use the code to set up an environment and just play around in the REPL console. In terms of, I mean, so like JavaScript, all the scripting languages kind of have the same kind of tooling for their debuggers. You'll stick some statement in somewhere that drops you in the REPL console in your local scope. And then all the compile languages have something that's a more formalized set of tools for debugger where you can put in the breakpoint statements and the like. And then of course they cross. So there's tooling in scripting languages that let you drop in breakpoints. And then in recent years, particularly with the advent of Jupyter notebooks, people have started adding in REPL consoles so that you can do C++ from the same sort of thing as IRB. Instead of having to compile your whole thing, you can write a chunk of code, compile and link it, write a chunk of code, compile and link it. Well, we can call it there. Thank you for coming to my talk.